warm wishes to you all. Myself, Sankareshwari, Assistant Professor of Physics, V.V. Vanniya Perumal College for Women, Virudhunagar. In this video, I am going to explain about nuclear reactor. Atom. Atoms are the basic particles of the chemical elements. Atoms consist of a heavy central nucleus which is surrounded by a cloud of negatively charged particles called electrons. Inside the atom, in the nucleus, the protons and neutrons are held together. The protons are positively charged particles and the neutrons are neutral particles. So, the number of protons is called as the atomic number. This number uniquely identifies the chemical element. The magnitude of the proton is same as that of the electron. So, nucleon is nothing but the combined proton and neutron. Normally, the nucleon denotes the mass number of an atom. So, the mass number is the sum of protons and neutrons. So, the nucleon is the sum of proton and neutron and nucleus is denoted by ZXA. Z is the atomic number, A is the mass number. The atomic number indicates the number of protons or electrons. So, A is the mass number, which is nothing but the sum of protons and neutrons. X is the chemical symbol of species. So, from this we can calculate the number of neutrons by A minus Z. So, for example, in chlorine atom, the mass number is 35, atomic number is 17. So, the neutron number is 18. The nucleus can be classified into isotopes, isotones, mirror nuclei, isobars and isomers. Let me explain one by one. Isotopes are the nuclei with same atomic number but different mass number. Isotones are the nuclei with same neutron number. Mirror nuclei are the nuclei in which the protons and neutrons are interchanged. That is, the number of protons in one nuclei is equal to the number of neutrons of another one. Isobars are the nuclei with same mass number but different atomic number. Isomers are the nuclei in which the two nuclei are having same mass number and same atomic number but they differ by their internal structure. Nuclear forces are the forces that act between the nucleons to bind them into the nucleus. So, the nuclear forces are the strong attractive forces. So, in order to overcome the electrostatic repulsion between the protons inside the nucleus, the nuclear force must be strong enough. There are three kinds of attractive forces in the nucleus. They are neutron-neutron interaction, that is, the force acts between two neutrons. Second one, neutron-proton interaction. In this, the nuclear force acts between the neutron and proton. Third one, proton-proton interaction. Here the nuclear force acts between two protons. Then the characteristics of the nuclear forces are given. So, the nuclear forces are effective only at short ranges. This means that the radius of the nucleus is only 10 power minus 15 meter. So, the nuclear force is effective only inside the nucleus. Nuclear forces are charge independent. That is, the nuclear force exists between two protons or two neutrons or between a proton and a neutron. The nuclear forces are the strongest forces in nature. So, the nuclear force should be strong. Then only it can overcome the force of repulsion between two protons. Then the nuclear forces have saturation property. It means that the nuclear force acts between only the neighboring nucleons. Binding energy is defined as the minimum amount of energy which must be supplied to the nucleus to break it into its constituent nucleons. So, nuclear energy is the form of energy which is released from the nucleus of atoms. The energy can be released either through fission process or through fusion process. So, during the nuclear fission or fusion processes, a large amount of heat energy is liberated. This heat energy is used to produce electricity. So, the nuclear fission means a heavy nucleus is break into two or more lighter nuclei. So in this process a large amount of energy will be liberated. So nuclear fusion means two or more light nucleus can be combined to form heavy nucleus. So this is the pictorial representation of nuclear fission process. Here uranium-235 nucleus is bombarded by one neutron, then it becomes unstable nucleus, then it breaks up into two components, barium and krypton. In addition with the two components, 3 neutrons are also released and a large amount of energy is also released. So chain reaction. It is a self-propagating process in which the number of neutrons goes on multiplying rapidly, almost in geometrical progression during the fission till the whole material is disintegrated. That is, the neutrons are multiplying till the material is completely disintegrated. So there are two types of chain reaction. They are controlled chain reaction and uncontrolled chain reaction. So the controlled chain reaction occurs in nuclear reactor, uncontrolled chain reaction occurs in atom bomb. So during the fission a large amount of energy is released. So the atom bomb is due to the uncontrolled chain reaction. So a very large amount of energy is liberated within small interval of time. So it is not possible to use such amount of huge energy. So the maximum part of the energy is wasted. But in a nuclear reactor, the fission process occurs under control process. So here the chain reaction can be controlled. After some time, a steady state is established. Under a steady state, the rate of energy production also attains a constant level. So the device in which the energy is released at a given rate is known as nuclear reactor. So the nuclear reactor contains the following 5 main components. They are fissionable material called fuel, moderator, neutron reflector, cooling system, the safety and control systems. So fissionable substance means the fuel used in the nuclear reactor. So normally uranium, thorium, plutonium isotopes are used as fissionable substance. So moderator, the function of the moderator is to slow down the highly energetic neutrons produced in the fission process. So normally heavy water, graphite, beryllium etc. are used as moderators. So ideally moderators have low atomic weight and low absorption cross section for the neutrons. Neutron reflectors. So with the help of neutron reflectors on the surface of the reactors, we can eliminate the leakage of neutrons. So here the materials of high scattering cross section and low absorption cross section are used as good reflectors. So the cooling system removes the heat evolved in the reactor core. So the coolant or heat transfer agent like water, steam, helium, carbon dioxide, air and certain molten metals and alloys is pumped through the reactor core. Then heat through a heat exchanger, the coolant transfers heat to the secondary thermal system of the reactor. Next one, control and safety system. The control systems enable the chain reaction to be controlled and prevent it from spontaneously running away. So this is accomplished by pushing control rods into the reactor core. Normally the rods are made by cadmium or boron. So they have large neutron absorption cross section. These rods absorb the neutrons and cut down the reactivity. By pushing inside the rods, the operation of the reactor can be made to die down. By pulling them out to build up. The safety systems protect the space surrounding the reactor against neutron flux and gamma rays existing in the reactor core. So this is achieved by surrounding the reactor with massive walls of concrete and lead which would absorb neutrons and gamma rays. So next one is the power reactor. The heat generated in a nuclear reactor is used for producing power in a nuclear power plant. So the figure shows the components of a power reactor. So at the center the nuclear fuel material is kept and here the control rods are cadmium rods and then heat transfer fluid is circulated in the tubes. So a quantity of enriched uranium in the form of pure metal or solution of a soluble salt in water constitute the center of the heat energy source. That is, the uranium is used as the fuel and a large quantity of heat is produced in the fission process. The cadmium rods regulate the temperature to a predetermined value. If it is desired to bring down the temperature, the cadmium rods are pushed down to the reactor to absorb the neutrons. If the temperature has to be raised up, then the cadmium rods are pulled up a little. A fluid is circulated through the shielded reactor and heat exchanger. The hot fluid, while flowing through the heat exchanger, converts water into steam. Then the steam is used to run the turbine. Then the electricity will be generated. So nuclear reactors are used to generate the nuclear power. So that is to generate electricity. And nuclear reactors are useful in producing a large number of radioisotopes. Reactors produce a number of radioactive materials needed for research purposes. Radiation hazards. So biosphere will be contaminated by two major sources. People receive some natural or background radiation exposure from sun, radioactive elements in the soil, rocks and internal radiation. The second source of radiation contamination is man-made. This includes nuclear reactors, materials released through accidents or through the testing of nuclear devices or in the atmosphere. Thank you.